There is a silence in the cosmos that we can never truly know. It is a quietude born not of peace, but of vacuum, an emptiness so profound it stretches between worlds, across the gulf of galaxies. For billions of years, from our small blue oasis, we have always looked up into it. We have charted the serene, predictable waltz of the planets and connected the distant points of light into comforting myths. We imagined the heavens as a clockwork masterpiece, a reflection of order, a divine and tranquil ceiling. We were profoundly, beautifully, and terrifyingly mistaken. The serene night is an illusion. The quiet is a lie, a veil drawn across a theatre of such violence and bewildering peculiarity that it beggars the human imagination. Our telescopes, our probes, our calculations, they are not just tools of measurement. They are windows into a cosmic asylum, a universe far stranger than we ever dared to dream. The things we have found out there in the great darkness do not just challenge our science, they challenge our sanity, our very definition of what is real and what is possible. This is the story of those discoveries, the story of the anomalies, the monsters, and the ghosts that haunt the fabric of space-time. Our journey into the bizarre begins with an idea of endings. For eons, we saw the stars as eternal fires, immortal beacons, but we now know that they live and, more importantly, they die. And some die in a manner so spectacular, so catastrophically violent, that their death rattles echo across the universe. When a star many times more massive than our sun runs out of fuel, its own colossal gravity, a force held at bay for millions of years, wins the final, decisive battle. The core of the star collapses inward upon itself. It falls at a quarter of the speed of light, an unstoppable implosion that triggers a final, defiant explosion, a supernova. For a few weeks, this single dying star can outshine its entire galaxy, a final, glorious scream into the void. But what of the corpse it leaves behind? What remains at the heart of the fire? For the most massive stars, the answer is a gateway to infinity. But for a slightly smaller class, the remnant is something else. Something that stretches the laws of physics to their breaking point. Imagine taking a mountain, not a small one, but Mount Everest. Visualize its sheer scale, its 8,800 meters of rock and ice. Now, imagine taking not just that mountain, but the entire Himalayan range and crushing it, compressing it with an impossible force, until all of that mass, all of that substance, fits into a space no larger than a common sugar cube. The object you are holding in your mind is a pale imitation of the reality of a neutron star. These are the densest objects in the known universe that are not black holes. They are the collapsed cores of giant stars, stellar zombies, packing the mass of 1.5 of our suns into a perfect sphere only 20 kilometers across, a city-sized star. If you could somehow acquire a single teaspoon of its material, that spoonful would weigh over 1 billion tons on Earth. It would plunge through the planet's crust and mantle as if they were nothing more than mist. Its surface gravity is 200 billion times stronger than Earth's. Its magnetic fields are 1 trillion times more powerful. It is an object so extreme, its very existence sounds like a fiction. First theorized in the 1930s by Walter Baade and Fritz Zwicky, they were considered little more than a mathematical curiosity for decades. How could matter possibly behave this way? The answer lies in the fundamental nature of reality. The immense pressure of the gravitational collapse is so great that it overcomes the forces that keep atoms separate. Electrons are smashed into protons, merging to form a sea of pure neutrons, packed together as tightly as the universe will allow. It is a single, gigantic atomic nucleus the size of Manhattan. This is no longer matter as we know it. It is neutronium. In 1967, a young graduate student named Jocelyn Bell Burnell, working at Cambridge University, was monitoring data from a new radio telescope. She noticed a strange, repeating signal, a pulse so regular, so precise, it beat like a cosmic metronome every 1.33 seconds. For a moment, the team entertained the most tantalizing of possibilities. Was this a beacon? A message from little green men? They labeled the signal LGM-1. But soon they found other, similar signals from other parts of the sky. They had not discovered aliens. They had discovered something perhaps even stranger. They had found the neutron stars. These objects spin at incredible speeds, hundreds of times per second, and as they whirl, their intense magnetic fields channel beams of radiation out into space from their poles. If one of these beams happens to sweep across our line of sight, we see a pulse of radio waves. A celestial lighthouse, spinning in the dark, the ghost of a long-dead sun, still screaming its existence across the void. But what happens when the dying star is even more massive? What happens when the force of gravity is so absolute, so completely unopposed, that not even the dense packing of neutrons can stop it? The answer is the most enigmatic and terrifying concept in all of cosmology. The collapse does not stop. The core continues to shrink, past the size of a city, past the size of a marble, past any dimension we can comprehend, into an infinitely small, infinitely dense point of singularity. Around this point, gravity becomes so powerful that it warps the very fabric of reality. It creates a one-way door in the universe, a region of space-time from which nothing, not even light itself, can escape. It creates a black hole. The idea is not new. As far back as 1783, the English natural philosopher John Michell speculated about dark stars, objects so massive that their escape velocity would exceed the speed of light. Later, Einstein's theory of general relativity provided the mathematical framework. His equations showed that mass doesn't just pull on things, it bends the geometry of space and time around it. Imagine space-time is a vast, flat, rubber sheet stretched taut. A planet like Earth places a small divot in this sheet. Other objects rolling nearby follow the curve, creating what we perceive as an orbit. Now, imagine placing an object of immense density on that sheet. It doesn't just create a divot, it punctures a hole right through it, an infinitely deep well from which there is no return. This is a black hole. The edge of this well is called the event horizon. It is not a physical surface, but a threshold, a point of no return. Crossing it is an irreversible act. Once you pass the event horizon, all possible paths in spacetime lead in only one direction, toward the singularity at the center. The future becomes a place, not a time. For decades, these two were just theoretical monsters, lurking in the complex equations of relativity. But the evidence began to mount. We saw stars orbiting, nothing, vast, empty points in space, with stellar partners whipping around them at incredible speeds, tethered by an unseen, immense gravitational force. We saw matter from companion stars being siphoned off, forming a swirling, superheated disk of gas around the black hole. As this material spirals to its doom, it is heated to millions of degrees, blasting out X-rays that our telescopes can detect, the final, agonizing scream of matter before it is silenced forever. And then, in 2019, humanity achieved the impossible. The Event Horizon Telescope, a global network of observatories acting as a single Earth-sized lens, captured the first ever direct image of a black hole silhouette. It was a monster named M87*, 6.5 billion times the mass of our Sun, residing in a galaxy 55 million light-years away. The image was not of the hole itself, for that is by definition invisible. It was a picture of its shadow, a perfect circle of blackness, backlit by the ghostly glowing ring of superheated plasma, trapped in its gravitational embrace. We had stared into the abyss, and for the first time, the abyss stared back. The black hole was no longer a theory. It was real, a fundamental breakdown of our known physics, a wound in the universe, existing in plain sight. The universe, it turns out, is not only filled with visible monsters. The most profound strangeness lies in what we cannot see at all. For most of the 20th century, we built our models of the cosmos based on the things we could detect: stars, gas, dust, galaxies. We added up all the light, calculated the mass, and assumed that was it. We were off by 95%. The story of this revelation begins in the 1930s with the brilliant, if famously cantankerous, Swiss astronomer Fritz Zwicky. While studying the Coma cluster of galaxies, he noticed something deeply wrong. The galaxies within the cluster were moving far too quickly. Based on the visible mass of all their stars, the cluster shouldn't have enough gravity to hold itself together. The galaxies should have flown apart, dissipating into the void ages ago. Zwicky proposed that there must be some form of unseen matter, which he called dunkle materie, or dark matter, providing the extra gravitational glue. His idea was largely ignored for 40 years. Then, in the 1970s, an astronomer named Vera Rubin made it impossible to ignore. She was studying the rotation of individual spiral galaxies. Logic dictates that stars at the outer edges of a galaxy should move more slowly than those closer to the bright, dense center, just as Neptune orbits the Sun more slowly than Mercury. But that is not what she found. Over and over again, in galaxy after galaxy, Rubin's meticulous observations showed that the outer stars were moving just as fast as the inner ones. It was a stunning violation of Newtonian physics. The only way this could be possible is if the galaxies were embedded in a vast, invisible halo of some mysterious substance, its mass extending far beyond the visible light of the stars. Vera Rubin had confirmed Zwicky's ghost. Today, we know that this dark matter constitutes about 27% of the total mass and energy of the universe. The ordinary matter that makes up you, me, the Earth, the Sun, and every star you can see in the night sky, all of it, amounts to a mere 5%. We are the cosmic rounding error. So what is this stuff? The honest answer is, we have no idea. We know what it is not. It is not just dim stars or cold gas. It does not interact with light or any other form of electromagnetic radiation, which is why we cannot see it. It is transparent, ethereal. It passes through us, through the Earth itself, as if we were not here, yet its gravitational influence is the architect of the universe. It is the invisible scaffolding upon which galaxies form and cluster. Without dark matter, there would be no galaxies, no stars, no planets, no us. We live and breathe because of a substance we cannot see, cannot touch, and cannot comprehend. A cosmic phantom that dictates the fate of everything. But the phantom has a partner, and it is even more perplexing. If dark matter is the universe's mysterious glue, there is another force acting as a cosmic propellant. For most of history, cosmologists debated two possible fates for the universe. Would gravity eventually halt the expansion from the Big Bang and pull everything back together in a big crunch? Or would the expansion continue forever, slowing but never quite stopping? In 1998, two separate teams of astronomers set out to settle the question. They used distant supernovae as standard candles to measure the expansion rate of the universe throughout its history. They expected to find the expansion was slowing down. Instead, they found something that turned cosmology on its head. The expansion of the universe is not slowing down, it is accelerating. Something is actively pushing space-time apart, fighting against gravity. This discovery was so shocking, so contrary to all expectation, that the scientists who found it spent months trying to prove themselves wrong. But the data was undeniable. They had discovered the effects of what we now call dark energy. This is the dominant force in the cosmos, making up an estimated 68% of everything that exists. It appears to be a property of space itself, a kind of intrinsic energy of the vacuum. As more space is created through expansion, more of this energy comes into being, which in turn pushes space to expand even faster. It is a runaway process. Imagine baking a loaf of raisin bread. The dough is space-time and the raisins are galaxies. As the dough rises, all the raisins move farther apart from each other. This is the standard model of cosmic expansion. But now, imagine that the dough itself has some magical property that causes it to expand at an ever-increasing rate. The raisins aren't just moving apart, They are accelerating away from each other. This is the universe we live in, and the implications are profound and chilling. If this acceleration continues, it points toward a lonely future. First, the distant galaxies will accelerate away so fast that their light will no longer be able to reach us. They will vanish from our sky one by one. Our cosmic horizon will shrink, leaving our own Milky Way galaxy as a solitary island in an endless, empty void. Eventually, in the most extreme scenarios, the repulsive force of dark energy could become so strong that it overcomes all other forces, tearing apart galaxies, solar systems, planets, and even atoms themselves in a final, cataclysmic Big Rip. We have discovered that the vast majority of our universe is composed of two substances that are complete mysteries, one pulling it together, the other pushing it apart in an epic, unseen cosmic battle that will determine the ultimate fate of reality itself. Beyond the grand, invisible structures of the cosmos, the strangeness also comes to us in whispers, in fleeting signals from the deep. On a summer night in 1977, at the Big Ear Radio Telescope in Ohio, astronomer Jerry Amon was reviewing printouts of data from a search for extraterrestrial intelligence. Suddenly, he saw a sequence of characters that made his heart race. Seise Hukasingo. It was a signal of stunning intensity and coherence, lasting for 72 seconds, broadcast on a frequency that is largely forbidden for terrestrial transmitters. It came from a narrow patch of sky in the constellation Sagittarius, and it bore all the hallmarks of a deliberate, non-natural transmission. In the margin of the printout, Amon circled the code and wrote a single word: WOW. The name stuck. For decades, the WOW signal has remained the single most compelling potential candidate for an alien message ever received. We have pointed our telescopes back to that same patch of sky countless times. We have found nothing. The signal never repeated. It was a cosmic doorbell that rang once and then fell silent forever. Was it a secret military satellite? A unique, undiscovered natural phenomenon? Or was it exactly what it appeared to be? A powerful, focused transmission from an advanced civilization which we happened to intercept for one brief, tantalizing minute. As it swept across our tiny corner of the galaxy, we may never know. It remains a singular, maddening question mark, hanging in the cosmic dark. More recently, a new auditory mystery has emerged. Since 2007, radio telescopes around the world have been detecting something known as fast radio bursts, or FRBs. These are astoundingly powerful blasts of radio waves, lasting for only a few thousandths of a second. In that tiny sliver of time, some of them release more energy than our sun does in an entire day. They are not subtle. They are the cosmic equivalent of a flashbulb going off on the other side of the universe. For years, we had no idea where they were coming from. They seemed to be random, appearing all over the sky. Then, we managed to pinpoint the origin of a repeating FRB to a tiny, unimpressive dwarf galaxy 3 billion light-years away. What could possibly generate such an immense amount of energy in a millisecond? The leading suspect is a type of neutron star called a magnetar, an object with a magnetic field so ludicrously powerful it could wipe the data from every credit card on Earth from halfway to the moon. Starquakes on the surface of these magnetars could, in theory, produce the energy we see. But other possibilities, from colliding black holes to, yes, the energy signatures of alien technology, remain on the table. The universe is shouting at us in short, brilliant bursts, and we are only just now beginning to learn the language. For most of human history, the idea of other worlds was confined to philosophy and fiction. Now, we know of thousands of them. The age of exoplanet discovery has revealed a menagerie of worlds, so bizarre they make our own solar system look tame and unimaginative. We have found planets that defy easy categorization. Take 51 Pegasi b, the first exoplanet discovered orbiting a sun-like star. It's a gas giant, a hot Jupiter, half the mass of our own Jupiter, but orbiting so perilously close to its star that its year lasts only 4 Earth days. Its surface temperature is a scorching 1,000 degrees Celsius, its atmosphere constantly being blasted away into space. This was not a world astronomers expected to find. It shattered our models of planetary formation and opened the floodgates. Since then, the discoveries have only grown more outlandish. We have found a planet named HD 189733b. From a distance, it is a beautiful, deep azure orb, much like our own Earth. But this is no welcoming water world. The brilliant blue color comes from an atmosphere laced with silicate particles. It is a world where the clouds are made of molten glass and where 7,000 km/h winds whip this glass sideways, creating a perpetual, hellish storm of flying shards. Or consider 55 Cancri E, the diamond planet. It is a super-Earth, twice our planet's size, orbiting so close to its star that its surface is likely molten. But its chemical composition is what sets it apart. It is believed to be incredibly carbon-rich. Under the immense pressures and temperatures of its interior, that carbon would be compressed into its most stable form. It is a world where a thick crust of graphite may sit atop, a mantle of pure, solid diamond, trillions upon trillions of carats. A treasure world that would incinerate any probe we sent to it. We have found planets orbiting 2 stars, like Tatooine from science fiction. We have found rogue planets, ejected from their home systems, doomed to wander the cold, dark space between stars for eternity. Each new discovery is a reminder that the universe has far more imagination than we do, and that the definition of a planet is broader and wilder than we ever conceived. The strangeness of the universe is not just in its individual objects, but in its grand architecture. When we map the positions of galaxies, on the largest scales, we expect to see a relatively uniform distribution. Instead, we find a cosmic web, a delicate filigree of galactic superclusters, and long, stringy filaments surrounding vast, empty regions of space. These are the cosmic voids, and the most terrifying of them is the Bortes void. Discovered in 1981, it is a colossal, almost spherical region of space, 330 million light-years in diameter. It is so large that if our own Milky Way galaxy were at its center, we would not have known other galaxies existed until the 1960s. It is often called the Great Nothing. This is an exaggeration. The void is not completely empty. It contains perhaps 60 galaxies, when a region of that size should contain thousands. It is a desert in the cosmos, an area of profound underdensity. How does such a gaping hole in the universe form? Our best models suggest that in the early universe, as matter began to clump together under gravity, smaller voids merged and grew, like bubbles in a rising loaf of bread. The Bortes void is simply one of the largest bubbles we have found. To stand at its edge and look in would be to witness an ocean of blackness, unimaginably vast, a silent testament to the lumpiness of creation. It is a stark reminder that emptiness is as fundamental a component of the cosmos as substance. On the other side of the scale, we have found the opposite. Immense structures, walls of galaxies bound by gravity that represent the largest known objects in the universe. The Hercules Corona Borealis Great Wall, for instance, is a galactic filament that stretches for a staggering 10 billion light-years. That is more than a tenth of the diameter of the entire observable universe. Its existence challenges our cosmological principle that the universe, on large scales, should be roughly the same everywhere. This structure is simply too big to have formed in the 13.8 billion years since the Big Bang, and yet, there it is, a cosmic continent of matter, so vast it should not be possible, a flaw in our understanding of how everything came to be. Perhaps the most unsettling discoveries are those that offer no easy answers, the ones that leave the door wide open to speculation that borders on the fantastic. Enter KIC 8462852, better known as Tabby's star. It is an otherwise unremarkable star, slightly larger than our Sun, located about 1,400 light-years away. But in 2015, citizen scientists analyzing data from the Kepler Space Telescope noticed it was behaving in a way no star should. It was dimming. Not in a regular periodic way, like a planet passing in front of it, but in strange, erratic, and massive dips. Sometimes it would dim by only a few percent. Once, its light dropped by a staggering 22%. This implies that something enormous, something 1,000 times the area of Earth, was blocking its light. Astronomers scrambled to find a natural explanation. A swarm of comets? Possible, but the sheer number of comets required to block that much light would be astronomical. An interplanetary dust cloud? Perhaps, but the dimming events are too sharp and irregular. A planetary collision? It would create a cloud of debris, but that cloud should glow with infrared heat, which we do not detect. Every conventional explanation has a problem. And so, reluctantly, some astronomers have been forced to consider the most extraordinary possibility of all. What if the object blocking the light is not natural? What if it is an artifact, a vast, artificial construction, a Dyson swarm of solar collectors, built by an incredibly advanced civilization to harness their star's energy? It is a wild, sensational idea, and it is by no means the leading theory. But the fact that it cannot be entirely dismissed, the fact that a natural phenomenon has proven so difficult to identify, is a testament to the sheer weirdness of the object. Tabby's star is a lesson. It teaches us that after centuries of observation, the universe can still present us with a mystery so profound that even the most outlandish science fiction concepts must be given a moment's consideration. From the crushing density of neutron stars to the absolute nothingness of black holes, from the invisible dominance of dark matter and dark energy to the fleeting whispers of unknown origin, from worlds of glass and diamond to voids of unimaginable emptiness, we set out to map a clockwork cosmos and found instead a carnival of wonders. Every time we build a new instrument, every time we look at the sky, in a new wavelength or with greater precision, we do not find the universe becoming simpler, more orderly. We find it becoming stranger, more complex, more surprising. Our knowledge is an expanding island in an infinite ocean of ignorance, and the larger the island becomes, the longer the coastline, where it touches the unknown. The strangest things in space are not just objects or phenomena, they are mirrors. They reflect the limits of our understanding, the fragility of our theories, and the boundless nature of what is still left to be discovered. They force us to ask the deepest questions. Are we alone? What is the ultimate nature of reality? What is our place within this vast, bewildering, and magnificent tapestry? Perhaps the single strangest thing we have ever discovered in space, amidst all the cosmic monsters and impossible physics, is a small, watery planet in the unremarkable suburbs of an average galaxy. A world that has somehow produced a species capable of looking up, of wondering, and of slowly, painstakingly beginning to understand. The greatest anomaly in the cosmos might just be consciousness itself, and our journey into the strangeness has only just begun.